In this tutorial, we are going to learn about reinforcement learning through simple simulation. Reinforcement learning is widely used in robotics and industrial automation. The program used in this video is available from the description below. In short, machine learns itself relying on feedback from an environment. Reinforcement learning involves an agent, a set of states, and a set of actions per state. The purpose of reinforcement learning is to teach the agent an optimal policy that maximizes the reward function that accumulates from the immediate rewards. For example, let's assume there is a robot moving inside a maze. If the robot moves up, it will hit the wall and will get negative reward, for example -1. If the robot moves down, it will hit the wall again and will get negative reward. Finally, if the robot moves to the goal successfully, it gets positive reward of 3 and in total 1, but if the robot moves right at the first turn it will get a total reward of 3. In this way, the robot learns that it should go right to get maximum reward. In reinforcement learning, there is no need in training data sets. Now, let's learn about one of the most famous reinforcement algorithm, Qlearning. Qlearning is a model-free reinforcement learning algorithm used to learn the value of an action in a particular state. It does not require a model of the environment. Qlearning finds an optimal policy in the sense of maximizing the expected value of the total reward over all successive steps, starting from the current state. Qlearning is an off-policy algorithm. It estimates the reward for state-action pairs based on the greedy policy, independent of the agent's actions. This feature will be reviewed in this tutorial. This is the function that calculates the quality of a state-action combination. The first term represents how fast does Q change. In the second term we set how much influence reward will have on the next Q value. The third term represents the maximum reward that can be obtained from the next state. In this tutorial we are going to solve a maze using reinforcement learning. We will set a negative value of -2 for walls, a positive value of 3 for the goal, and 0 for usual road. The start point is at the upper left side of the maze. Goal could be anywhere but this time it is at the right bottom side of the maze. Now, let's dive into the code. Firstly, robot state is initialized. This initial state is the starting point from which robot begins learning. Then, we create actions. Actions are created for each position of the maze. Note that at the boundary of the maze, actions which lead out of the maze are excluded. Symbols 0, 1, 2, 3 represent down, left, up and right movements, respectively. Here are definitions of the moves. Each move corresponds to an action number. Finally, Q is initialized. Q is a three-dimensional array because we have 4 actions for each maze coordinate. Calculations are done in the act function. First, action is selected. The selection of the action is based on epsilon greedy algorithm. If random number is more than epsilon value, then action with the highest Q is selected. If random number is smaller than epsilon value, then random action is selected. Then, moving direction of the agent is selected based on selected action. After updating reward and Q, New state is calculated and then calculation continues until agent reaches the goal. Now, let's do some simulation. For maze of this size, calculation will take about 2 minutes. As you can see, we were able to find the right path.